As we move forward in our CompTIA PenTest Plus PT0-003 certification course, let's dive into our new section, Vulnerability Discovery and Analysis. This segment is crucial for anyone looking to master penetration testing, given that discovering and analyzing vulnerabilities form the backbone of effective security assessment. In this introductory slide, we'll cover the following key points. 1. Overview of vulnerability discovery and analysis. We'll provide you with a foundational understanding of what vulnerability discovery entails and what the subsequent analysis looks like. This will set the stage for more detailed discussions to follow. 2. Importance in penetration testing. Here, we'll underline why vulnerability discovery and analysis are vital components of penetration testing. A thorough grasp of these concepts ensures that testers can identify security gaps accurately and recommend robust countermeasures. 3. Key objectives and techniques. Finally, we'll outline the primary objectives you should aim to achieve in vulnerability discovery and introduce some high-level techniques that you will learn to use effectively throughout this course. In our next slide, we'll delve into the types of scans you can perform during vulnerability discovery and discuss the importance of comprehensive scanning. Let's proceed to understand these scanning methods in detail. Moving on to slide 2, let's dive into the different types of scans that you'll encounter in vulnerability discovery and analysis. First, we'll introduce the various types of scans. These include network scans, web application scans, database scans, and container scans, among others. Understanding the distinctions and purposes of each type is crucial for performing thorough vulnerability assessments. The importance of comprehensive scanning cannot be overstated. By employing various scanning techniques, we can get a holistic view of an organization's security posture. Each type of scan has its own strengths and addresses different aspects of the environment, ensuring that no vulnerabilities are overlooked. In the next slide, we will explore container scans in detail, including an overview, techniques, and tools. Specifically, we'll demonstrate how to run a Trivy scan on a Docker image using the command Trivy image my Docker image. This will give you practical insight into securing containerized applications. Let's proceed to slide 3 to learn more about container scans. In the last slide, we discussed the various types of scans essential for ensuring robust security within your systems. We highlighted the significance of comprehensively scanning your environments to identify potential vulnerabilities effectively. Now, let's dive into the specifics of container scans. Container scans involve examining container images to detect vulnerabilities, misconfigurations, and compliance issues before they are deployed. Tools and techniques for container security are specifically designed to address the unique challenges containers present. For instance, a popular tool used for this purpose is Trivy. Trivy is known for its efficiency in scanning container images for vulnerabilities. Here's how you can run a Trivy scan on a Docker image. Bash Trivy image my Docker-image. This simple command initiates a thorough scan of your specified Docker image, my Docker image, and identifies any potential security risks associated with it. Next, we'll explore Sidecar scans, including their methodology, use cases, and benefits, along with a practical example of implementing a Sidecar container for security scanning. In the previous slide, we discussed various aspects of container scans, including an overview of container scan techniques, tools for container security, and a practical example of running a Trivy scan on a Docker image. Now let's delve into the concept of Sidecar scans. Introduction to Sidecar scanning methodology. Sidecar scanning involves running an additional container, known as a sidecar, that performs security scans in parallel with your primary application container. This methodology builds on the principles of separation of concerns and microservices, ensuring that security tasks do not impede the performance of your main application. Use cases and benefits. Sidecar scanning is particularly useful in dynamic environments such as Kubernetes, where it can help in continuously monitoring and identifying security vulnerabilities in real time. The sidecar can be automatically deployed and scaled, providing seamless integration and enhanced security measures without significant overhead. Example: implementing a sidecar container for security scanning. Here's a simple example scenario. Suppose you have a web application running in a primary container. You can deploy a Sidecar container alongside this primary container to handle the security scanning of logs, network traffic, or even the application code. This approach allows the Sidecar to monitor for potential threats and vulnerabilities while your application continues to operate without interruption. In the next slide, we will examine application scans, where we'll cover the different types of application scans, such as DAST, IST, SCA, and SAST, and discuss their importance in maintaining robust application security. On this slide, we dive into application scans, a crucial aspect of maintaining robust application security. First, let's outline the types of application scans, which include Dynamic Application Security Testing, DAST, Interactive Application Security Testing, IAST, Software Composition Analysis, SCA, and Static Application Security Testing. Each of these methodologies serves a unique purpose, and collectively they form a comprehensive security posture for applications. DAST, or Dynamic Application Security Testing, focuses on identifying vulnerabilities in the runtime environment. IST, or Interactive Application Security Testing, combines elements of both DAST and SAST, providing real-time analysis and monitoring of applications as they run. SCA, or Software Composition Analysis, identifies vulnerabilities within open source and third-party components used in your application. Lastly, SAST, or Static Application Security Testing, examines the source code for security vulnerabilities at rest, providing an essential layer of protection by catching issues early in the development cycle. Understanding and implementing these types of scans is vital for fortifying the security of your applications. They help in identifying and mitigating risks before they become critical issues, ensuring a resilient and secure digital infrastructure. Now, moving forward, the next slide will delve deeper into Dynamic Application Security Testing, DAST, including techniques and tools such as running OWASP-ZAP for DAST scans. Now that we've covered the overview of application scans and their various types, DAST, IST, and SAST, let's dive deeper into Dynamic Application Security Testing, or DAST. DAST is a type of black box security testing that simulates external attacks on an application while it is running to identify security vulnerabilities. This technique allows us to see the application from an attacker's perspective and find security flaws that might be missed by other testing methods. There are numerous tools available for DAST, and one popular tool is OWASP-ZAP. OWASP-ZAP is an open-source tool that helps in finding security vulnerabilities in web applications. For instance, you can use the zap baseline.py script in OWASP-ZAP to perform a quick security scan on a target website like so. zap baseline.py-example.com. This script executes a baseline scan and provides a report on the identified vulnerabilities. In our next slide, we will explore Interactive Application Security Testing, IAST. This approach combines elements of both static and dynamic testing, offering real-time feedback on security threats as the application runs. We'll discuss how to integrate IAST into your CI/CD pipelines to enhance your application's security posture. On our previous slide, we covered Dynamic Application Security Testing, or DAST. We delved into the basics, the common techniques and tools used, and even walked through a practical example using OWASP-ZAP with the command zap-baseline.example.com. Now let's shift our focus to Interactive Application Security Testing, known as IAST. This slide will provide an introduction to IAST, highlighting its unique capabilities in identifying vulnerabilities during the execution of an application. Unlike DAST, which examines applications from an external perspective, IAST works from within the application, providing highly detailed insights into potential security issues. We will explore the techniques and tools that enable IAST, discussing how it integrates deeply into the application runtime environment. One key advantage is that IAST tools can be seamlessly integrated into continuous integration and continuous deployment (CI/CD) pipelines, allowing for real-time identification of vulnerabilities as part of your development workflow. The practical example will illustrate how to integrate IAST into your CI/CD pipeline, enabling automated and continuous security checks throughout the software development lifecycle. Next, in Slide 8, we will cover Software Composition Analysis, SCA. We'll introduce SCA, discuss the techniques and tools involved, and provide a concrete example of running dependency check to identify vulnerabilities in third-party libraries with dependency check project my project scans path to project. Now let's move on to software composition analysis. SCA is an essential practice for identifying and managing the open source components and third-party libraries within your software. This slide provides a brief introduction to SCA, where we will delve into its techniques and tools. One common tool for SCA is dependency check, which helps you identify known vulnerabilities in your project's dependencies. Here's an example of how you can run dependency check for a specific project using the command bash dependency project my project scan/path/project. This command will generate a report outlining any vulnerability, allowing you to take necessary actions to mitigate risks. In our next section, we will discuss static application security testing (ST) and look at an example of running Bandit for Python code analysis. On the previous slide, we discussed software composition analysis (SCA), including its introduction, techniques, tools, and an example of running dependency check for your project dependencies. Now, shifting our focus to static application security testing, or SAST, we'll delve into a critical area for identifying vulnerabilities within your codebase. First, we'll go over the introduction to SAST. It's a method used to analyze source code or compiled code to find security flaws. SAST tools examine the code in its non-running state, providing a way to uncover vulnerabilities that could be exploited once the code is deployed. Next, we'll look into various techniques and tools used in SAST. These tools help developers identify and rectify security issues early in the software development lifecycle, which can significantly reduce remediation costs and effort. Finally, we'll examine an example of running Bandit, a popular SAST tool for Python code. The command shown, bandit-r path to python/code, scans the specified directory recursively, analyzing Python files for vulnerabilities. It's a straightforward yet powerful command that integrates easily into your development workflow, giving you insights into security issues as you code. On the next slide, we'll explore infrastructure as code (IAC) scanning, emphasizing its importance, techniques, tools, and a practical example of running Chekhov for Terraform code. This is crucial for ensuring your infrastructure is as secure as your application code. Now that we've discussed static application security testing, or SAST, and explored how to use tools like Bandit for Python code, let's move on to our next essential topic, infrastructure as code (IAC) scanning. Infrastructure as code is a key practice in modern DevOps, allowing you to manage and provision computing infrastructure through machine-readable files rather than physical hardware configuration or interactive configuration tools. This makes it crucial to ensure that your IAC templates are free from security vulnerabilities and misconfigurations. When we talk about the importance of scanning IAC, we're focusing on identifying potential security risks before these configurations are deployed. This preemptive approach helps us avoid introducing vulnerabilities into our production environments. For techniques and tools, there are various options available to scan ISC files. One popular tool is Chekhov, which is designed to detect cloud infrastructure misconfigurations within Terraform, CloudFormation, Kubernetes, and ARM templates. In the example provided, running Chekhov for Terraform code is straightforward. Bash Chekhov-d's path to Terraform/code. This command instructs Chekhov to scan the specified directory for Terraform configuration files and report any security issues or policy violations it detects. Next, we'll be diving into source code analysis, where we'll discuss its importance, the techniques and tools used, and provide an example with SonarQube. Stay tuned. On this slide, we're moving on to source code analysis. Just as with infrastructure as code (IAC) scanning, analyzing your source code is crucial for identifying vulnerabilities and ensuring the security and quality of your applications. The importance of source code analysis lies in its ability to uncover potential bugs, security vulnerabilities, and code quality issues early in the development cycle. By doing so, you can address these issues before they make it into production, which can save time, reduce costs, and maintain the integrity of your software. There are various techniques and tools available for source code analysis. Static analysis tools, for instance, can scan your source code without executing the program. They provide insights into potential code issues purely based on the written code. On the other hand, dynamic analysis tools evaluate your code during runtime, providing a different set of insights and often catching issues that static analysis might miss. An example of a powerful tool used for source code analysis is SonarQube. SonarQube analyzes your source code and helps you maintain code quality by identifying bugs, vulnerabilities, and code smells. To run a source code analysis using SonarQube, you typically set up a SonarQube server and a SonarQube scanner, which is configured to scan your code repository. This process seamlessly integrates into your CI/CD pipeline, providing continuous feedback on your code's quality. Next, we will transition to mobile scans, where we will explore the techniques and tools specific to mobile security testing, including an example of using MobSF for mobile security testing. On this slide, we're shifting our focus to mobile scans, which are crucial for identifying vulnerabilities specific to mobile applications. Mobile scans encompass a variety of techniques and tools designed to test the security robustness of mobile apps thoroughly. We'll begin with a general introduction to mobile scans, discussing their significance in the context of overall application security. We then delve into some common techniques and tools used for mobile security testing. One noteworthy example we will explore is MobSF, or the Mobile Security Framework. MobSF is a comprehensive tool that allows for automated security analysis of mobile applications for Android, iOS, and Windows platforms. It can perform both static and dynamic analysis and is open source, making it accessible for wide use in security testing. To get MobSF up and running, we can simply use Docker to streamline the setup process. The command we would use is docker run -et -p 8000 OpenSecurity/mobile-security framework-mobs. This command pulls the MobSF image from Docker Hub and runs it on port 8000. We'll go through this process in detail and demonstrate how to use MobSF to conduct a mobile security scan. In the next slide, we'll transition into discussing network scans, covering an introduction to network scans and different types like TCP/UDP and stealth scans. These scans play a vital role in identifying network vulnerabilities, which we'll explore next. In the previous slide, we delved into mobile scans, discussing the introduction to mobile security scanning, techniques and tools for mobile security testing, and provided an example using MobSF for testing. Now in this slide, we will turn our focus to network scans. Network scans are essential for identifying vulnerabilities and potential entry points within a network. We will cover two primary types of scans: TCP and UDP scans, and stealth scans. Each type of scan has its importance and specific use cases in network security assessments. TCP/UDP scans, for instance, are fundamental for checking open ports, which can reveal services running on network devices, while stealth scans are used to perform network reconnaissance without alerting the target. In the next slide, we will dive deeper into TCP/UDP scans, exploring their importance, the techniques and tools available for conducting these scans, and provide a practical example using Nmap, a popular network scanning tool. The command shown in the slide will help you initiate a comprehensive TCP and UDP scan across a specified IP range. In the previous slide, we introduced the concept of network scans and discussed some basic types, namely TCP and UDP scans, as well as stealth scans. Now we'll delve deeper into TCP/UDP scans. Slide 14 focuses on TCP and UDP scanning. These scans are crucial because they help identify open ports and the services running on them, which is fundamental for assessing the security posture of a network. We'll discuss the various techniques and tools you can use for TCP and UDP scanning. One of the most common and powerful tools is Nmap. For example, to run a TCP/UDP scan using Nmap, you can use the following command: nmap-ss-u.655.392.168.1.024. Here, -ss initiates a TCP SYN scan, -su starts a UDP scan, and -p165535 specifies the range of ports to scan. The IP range 192.168.1.0/24 targets all hosts within that subnet. This comprehensive scan covers all possible ports, maximizing the chances of detecting any open port on the network. In the next slide, we will explore stealth scans in more detail, including their techniques and tools, and provide an example of how to execute a stealth scan using Nmap. Continuing from our discussion on TCP/UDP scanning, let's delve into stealth scans. Stealth scans are an essential technique when it comes to conducting network reconnaissance, particularly when you want to avoid detection by firewalls or intrusion detection systems. Unlike full connect scans, stealth scans send SYN packets and then evaluate the responses without completing the TCP handshake, making it more subtle and less likely to be logged. Various tools can be employed to perform stealth scans, but one of the most popular is Nmap, which is highly versatile and powerful. For instance, you can use the following command to run a stealth scan: esh nmap -t4.192.168.1./24. In this example, the .ss flag specifies the SYN scan, commonly referred to as a stealth scan, and the -t4 flag sets the timing template, which is faster and more aggressive but still maintains a level of stealth. Here, we're scanning the entire 192.168.1./24 subnet. Moving on, our next section will cover host-based scans, where we'll discuss their importance, the techniques and tools involved, and provide an example using OpenVAS for conducting a host-based scan. Stay tuned for a deeper dive into these essential security scanning techniques. Now that we've covered stealth scans and how to utilize Nmap for executing them, let's move on to host-based scans, which involve examining individual hosts within a network to identify potential vulnerabilities. In this slide, we'll discuss the importance of conducting host-based scans. These scans are essential for understanding the security posture of each host, detecting misconfigurations, vulnerabilities, and ensuring compliance with security standards. We'll also go over the various techniques and tools used for performing these scans. A popular tool for executing host-based scans is OpenVAS, which provides a comprehensive vulnerability assessment. For example, you can use OpenVAS to scan a host by configuring it to target specific IP addresses and identifying potential threats. In our next slide, we will delve into the differences between authenticated and unauthenticated scans and their significance in security assessments. We'll further explore an example where Nessus is configured for authenticated scanning to demonstrate its importance and effectiveness. On this slide, we'll be discussing the differences between authenticated and unauthenticated scans and their importance in security assessments. Authenticated scans are conducted with valid credentials for accessing systems, giving the scanner a deeper insight into the host. These scans can check for vulnerabilities that require legitimate access to be exploited, such as misconfigurations or weak passwords that wouldn't be visible from the outside. Unauthenticated scans, on the other hand, do not use credentials and only assess the vulnerabilities visible without logging in. These scans are quicker, but might miss critical issues that an authenticated scan could uncover. The importance of distinguishing between these two types of scans lies in how comprehensive your security assessment needs to be. Authenticated scans provide a thorough evaluation, revealing more potential security risks, while unauthenticated scans offer a rapid but less detailed overview of vulnerabilities. An example tool you can use for authenticated scanning is Nessus. Configuring Nessus for authenticated scanning involves setting up the correct credentials and ensuring proper permissions so that it can perform in-depth scanning of your network and systems. In the next slide, we'll dive into secret scanning, its importance, and demonstrate how to use TruffleHog for this purpose. Now that we've discussed the differences between authenticated and unauthenticated scans and their significance in security assessments, let's move on to another critical aspect of security: secret scanning. Slide 18 focuses on secret scanning, which is fundamental for identifying sensitive information, like passwords, API keys, and other confidential data that might be exposed within your code repositories. The importance of secret scanning can't be overstated, as exposed secrets can lead to serious security breaches. We'll delve into various techniques and tools used for secret scanning, and a popular tool for this purpose is TruffleHog. TruffleHog can search through your repositories to locate high-entropy strings and regex patterns that often signify secrets. Here's a practical example of using TruffleHog for secret scanning. TruffleHog regex entropy equals true, github.com my/repo.git. This command will scan the specified GitHub repository using both regular expressions and entropy-based detection to identify any potential secrets. Next, we'll explore the realm of wireless scans, we'll go over the different types, such as SSID, channel, and signal strength scanning. On this slide, we'll dive into wireless scans. Wireless scanning is a critical process used to identify wireless networks and their characteristics. There are several types of wireless scans, most notably SSID scans, channel scans, and signal strengths. SSID, which stands for Service Set Identifier, is essentially the name of the wireless network. Scanning for SSIDs helps identify available networks within range. Channel scanning, on the other hand, involves identifying the channels being utilized by wireless networks. This can help in understanding network congestion and in optimizing network performance. Signal strength scanning assesses the strength and quality of the wireless signal, which is crucial for ensuring reliable connectivity and diagnosing potential issues. On the upcoming slide, we'll zero in on SSID scanning specifically. We'll explore its importance, the techniques and tools used, and even see an example using Kismet, a popular tool for wireless network detection and analysis. Now that we've covered an overview of wireless scans, including SSID, channel, and signal strength scanning, let's focus on SSID scanning in more detail. SSID scanning is crucial for identifying wireless networks in your vicinity. This process allows you to not only find the names of the networks, but also understand their presence and distribution. There are several techniques and tools available for SSID scanning. For instance, one popular tool is Kismet. Kismet is a network detector, packet sniffer, and intrusion detection system that supports SSID scanning. By using Kismet, you can effectively map out all the SSIDs broadcasted in your area, giving you a comprehensive understanding of the wireless landscape. In the next slide, we'll dive deeper into channel scanning. This will include discussing its importance, various techniques and tools, and how to use tools like AeroDumpNG for this purpose. Continuing from our discussion on SSID scanning, in this slide, we will delve into the concept of channel scanning. Channel scanning plays a crucial role in wireless network analysis, as it helps identify which channels are being used by nearby Wi-Fi networks, which can be useful for diagnosing network issues and optimizing performance. Firstly, let's discuss the importance of channel scanning. Understanding which channels are crowded can help in reducing interference by selecting the least occupied channels for your network. This can significantly improve the stability and performance of your wireless connection. When it comes to techniques and tools for channel scanning, various options are available. One prominent tool used for this purpose is AeroDumpNG. It's a powerful command line tool used for network packet capturing and can provide comprehensive details about network traffic. To illustrate the usage of AeroDumpNG, consider this example command, AeroDump-NG WLAN0. Here, WLAN0 represents the name of the wireless interface you are scanning with. This command will start capturing packets and display a list of all the wireless networks in range, along with details such as the channel each network is using, signal strength, and much more. In the next slide, we will explore signal strength scanning, focusing on determining the strength and quality of Wi-Fi signals using tools such as Insider. Understanding signal strength is essential for optimizing placement of access points and ensuring reliable network coverage. Let's move on. All right, moving on to slide 22, where we will focus on signal strength scanning. In the previous slide, we discussed channel scanning and went over the significance of it, the methods employed, and tools like AeroDumpNG for practical application. Now, it's crucial to understand signal strength scanning, which plays an important role in wireless network assessments. First, let's talk about why signal strength scanning is important. Accurate signal strength measurement helps in determining the range and reliability of wireless networks. This scanning provides insights into connectivity issues, coverage gaps, and potential interference sources. There are different techniques and tools available for signal strength analysis. One prime example is Insider, a robust tool widely used for this purpose. With Insider, you can visually map out signal strength across different physical locations, allowing you to identify strong and weak signal areas. This data is essential for optimizing network performance and ensuring a reliable connection. By the end of this section, you should be comfortable using these tools to assess the signal strength and make informed decisions based on your findings. Next, we'll be diving into Industrial Control Systems, ICS vulnerability assessments. We'll introduce the key concepts, discuss various techniques and tools applicable, and emphasize the importance of manual assessments and port mirroring for a thorough analysis. Let's proceed to the next slide. As we move forward from discussing signal strength scanning, let's dive into a critical area of cybersecurity, the vulnerability assessment of industrial control systems, ICS. In this slide, we will cover the fundamentals of an ICS vulnerability assessment, highlighting the essential techniques and tools necessary for performing a thorough evaluation. We'll also emphasize the importance of manual assessment and port mirroring in identifying weaknesses that automated tools might overlook. Understanding the unique vulnerabilities within ICS environments is crucial, as these systems are integral to the operation of critical infrastructure and industries. By ensuring a robust vulnerability assessment process, we can help protect these essential systems from potential threats and cyber attacks. On the next slide, we'll delve deeper into the importance of manual assessment in ICS, exploring proven techniques and best practices to enhance the overall security posture. On our previous slide, we discussed the fundamentals of ICS vulnerability assessment, emphasizing the importance of manual assessment and the role of port mirroring. Now let's dive deeper into the aspect of manual assessment. Manual assessment in ICS environments is crucial because automated tools may not always capture the nuanced and context-specific vulnerabilities that an experienced human eye can detect. When manually assessing ICS systems, several techniques and best practices should be adhered to. These include reviewing system configurations, codes, and logs manually to identify discrepancies that tools might miss. Additionally, comprehension of the process flows and operational nuances aids in uncovering vulnerabilities specific to the industrial context. Understanding these intricacies allows us to conduct a thorough and accurate assessment, ensuring that no stone is left unturned. Next, we'll move on to discuss port mirroring, another critical component in ICS security. Now that we've discussed the importance of manual assessment in industrial control systems, let's move on to our next topic, port mirroring. On slide 25, we'll focus on introducing you to port mirroring, a fundamental technique used for monitoring and troubleshooting network traffic. We'll explore various techniques and tools associated with port mirroring, providing you with practical knowledge on how to implement it effectively. Specifically, we'll walk through an example of configuring port mirroring on a Cisco switch, demonstrating step-by-step instructions to help you apply this in real-world scenarios. Following this, in the next slide, we'll delve into essential tools for vulnerability discovery. This section will provide an overview of critical tools used in penetration testing, emphasizing their importance in maintaining robust security. Continuing from our discussion on port mirroring, we'll now shift our focus to slide 26, which introduces some essential tools for vulnerability discovery. In this slide, we'll provide an overview of the critical tools used in identifying vulnerabilities within systems and applications. These tools are indispensable in penetration testing and help security professionals identify potential weaknesses before they can be exploited by malicious actors. We'll delve into the importance of vulnerability discovery tools in analyzing the security posture of your network and applications. By using these tools effectively, you can proactively address potential security issues and strengthen your defenses. Next, we'll move on to slide 27, where we'll take a closer look at Nikto, a widely used web server scanner. We'll explore its capabilities, including how it can help in identifying known vulnerabilities and misconfigurations in web servers. We'll also walk through an example of running a Nikto scan using the command nikto example.com. Let's dive deeper into these tools and see how they play a pivotal role in our penetration testing toolkit. Now, let's delve into Nikto. Nikto is a widely used open-source web server scanner that checks for vulnerabilities. It can scan web servers for thousands of potentially dangerous files, outdated versions, and other security issues. Why is Nikto essential? Well, its capabilities in web server scanning are quite robust. It can easily detect various configuration and security errors in the web server and associated software. Let's look at an example to understand how to run a Nikto scan. The command is straightforward. You would use Nikto //example.com to initiate the scan. This will start scanning the specified URL and return a comprehensive report of any vulnerabilities found. In the next slide, we will discuss Greenbone OpenVAS, another crucial tool that extends beyond web server scanning to perform comprehensive vulnerability assessments. Slide 28 introduces us to Greenbone OpenVAS, a comprehensive tool for vulnerability assessment. Just like Nikto, which we discussed in the previous slide, Greenbone OpenVAS is highly proficient in identifying security issues, but it goes several steps further by performing an in-depth analysis of vulnerabilities across various system components. This tool excels in scanning for known vulnerabilities, and it provides detailed reports that are invaluable for identifying and prioritizing security weaknesses. To run a basic OpenVAS scan, you'll need to configure your OpenVAS environment first. Once configured, you can initiate the scan and analyze the results to improve your security posture. Now let's move on to the next section, which will focus on TruffleHog, a tool specialized in secret scanning. On the previous slide, we discussed Greenbone OpenVAS, highlighting its capabilities in vulnerability assessment and walking through an example of running an OpenVAS scan. Now let's turn our attention to TruffleHog. TruffleHog is a powerful tool for scanning repositories to find high-entropy strings, often indicative of secrets like passwords, API keys, or tokens. It's essential for identifying sensitive information that might have been inadvertently committed to your repository. For example, you can run TruffleHog with the following command: TruffleHog f regex entropy equals true, github.com/repo.git. This command will scan the specified repository for any potential secrets using regular expressions and entropy analysis. In the next slide, we'll be examining BloodHound, discussing its capabilities in enumerating Active Directory environments and providing an example of how to run it. Slide 30 focuses on BloodHound, a powerful tool for Active Directory enumeration. In this section, we'll cover an overview of BloodHound and its capabilities. BloodHound is designed to identify and analyze attack paths within Active Directory environments. It can map out user and computer relationships, demonstrating potential attack vectors that adversaries might exploit. For example, let's go through the process of running BloodHound. First, you need to import the SharpHound module with the command import module sharphound.ps1. Then, you can invoke BloodHound to start the enumeration process using invoke bloodhound-collection method all domain mydomain.local zip file name. This command will collect all the necessary data from the specified domain and save it into a zip file. We'll dive deeper into the analysis of the results in a later section. Next, we'll explore Tenable Nessus and its capabilities in vulnerability scanning on slide 31. Let's now move on to Tenable Nessus, which is another crucial tool in our cybersecurity toolkit, particularly for vulnerability scanning. Nessus is a highly regarded tool for identifying vulnerabilities within your network. It provides comprehensive scanning capabilities, enabling users to detect a wide array of potential security issues, from outdated software and missing patches to configuration errors that could be exploited by attackers. In the following example, we'll walk through configuring and running a basic Nessus scan. 1. First, you'll need to install the Nessus software on the machine from which you'll be performing the scan. 2. Once installed, launch the Nessus application and log in. 3. Navigate to the Scans tab and click on New Scan. 4. Choose a scan template that best fits your needs, such as Basic Network Scan. 5. Configuring the scan involves setting target IPs or ranges, scan schedules, and other parameters as necessary. 6. After configuring, you can initiate the scan by clicking the Launch button. By running this scan, Nessus will analyze the specified targets for vulnerabilities, providing a detailed report that lists any findings and recommending steps to remediate identified issues. Next, we'll explore PowerSploit, which is another versatile framework, especially valuable for post-exploitation tasks. In the previous slide, we discussed Tenable Nessus, its capabilities in vulnerability scanning, and how to configure and run a Nessus scan. Now let's move on to PowerSploit. PowerSploit is a collection of PowerShell scripts that are designed for post-exploitation tasks. It's highly valuable for security professionals who are performing penetration tests and need to move laterally within a network or gather detailed system information after gaining initial access. First, we'll cover an overview of PowerSploit and its primary functions. PowerSploit shines in post-exploitation scenarios, enabling you to execute commands, gather data, and persist on compromised systems. One of its key post-exploitation capabilities is reconnaissance. For instance, you can import the PowerSploit module using PowerShell by executing the command import module PowerSploit. After loading the module, a useful command is invoke recon, which helps in gathering information about the system and network environment. In the upcoming slide, we'll shift our focus to Gripe, a tool specializing in container vulnerability scanning. We'll explore its capabilities and how you can run a Gripe scan on your Docker images using the command gripe my Docker image. Let's continue to delve into Gripe's features and see how it integrates into your container security workflow. Now, let's move on to slide 33, where we'll discuss Gripe. In this section, we'll start with an overview of Gripe. Gripe is a powerful tool designed to scan Docker images for vulnerabilities. It excels in detecting security issues within containerized applications. Next, we'll look at its capabilities in container vulnerability scanning. Gripe performs detailed inspections of your Docker images, identifying any known vulnerabilities in the included packages and libraries. This capability is crucial for maintaining secure container deployments and ensuring your applications are free from critical security flaws. For a practical example, we'll demonstrate running a Gripe scan. The command to execute this is straightforward. Simply use gripe my Docker image. This command initiates an in-depth scan of the specified Docker image, listing all detected vulnerabilities so that you can address them proactively. In the following slide, we'll move on to Trivy, another excellent tool for scanning container images and infrastructure as code files. Now, let's move on from Gripe to another powerful scanning tool, Trivy. Trivy specializes not only in container vulnerability scanning, but also in infrastructure as code, IAC scanning. This makes it a versatile tool that can help secure both your container images and your IAC configurations, ensuring a more comprehensive security posture. Like Gripe, Trivy is straightforward to use with a simple command line interface. To run a basic container image scan with Trivy, you would use the following command: shtrivy image my docker-image. This command will analyze my Docker image for known vulnerabilities and provide you with a detailed report, making it easier for you to identify and remediate security issues. In the next slide, we'll dive into CubeHunter, a specialized tool for Kubernetes security scanning. Let's move on to slide 35, where we will discuss another essential tool in our vulnerability scanning toolkit, CubeHunter. CubeHunter is designed specifically for Kubernetes environments, providing robust security scanning capabilities to identify potential risks within your Kubernetes clusters. To give you a clearer picture, let's review its capabilities. CubeHunter can probe your Kubernetes clusters for various vulnerabilities and security inconsistencies. It's built to understand the unique architecture and components of Kubernetes, making it highly effective in discovering weaknesses that other general security tools might miss. For instance, you can run a CubeHunter scan on a remote cluster using a simple command. Here's an example: shell CubeHunter remote my-Kubernetes cluster. This command will initiate a comprehensive security scan of the specified Kubernetes cluster, enabling you to identify and mitigate vulnerabilities before they can be exploited. In the next slide, we will wrap up with a conclusion and review of the vulnerability discovery and analysis techniques we've covered, as well as discussing their importance in penetration testing and exploring the next steps for further learning. Let's now move on to the conclusion and review of our course content. This final slide will encapsulate the key takeaways and emphasize their importance in the context of penetration testing. Firstly, let's summarize the techniques we've discussed for vulnerability discovery and analysis. We've covered a range of methodologies, from manual inspection and automated scanning tools to the use of specialized frameworks like CubeHunter. Each technique offers unique insights and capabilities that can help identify potential weaknesses in your Kubernetes environment. Understanding these vulnerabilities is crucial not just for theoretical knowledge, but for practical application in penetration testing. Effective penetration testing enables you to proactively identify and address security flaws before they can be exploited by malicious actors. This is an essential aspect of maintaining a secure and robust Kubernetes infrastructure. As for the next steps, I encourage you to continue your learning journey. Delve deeper into specific tools, stay updated with the latest trends in Kubernetes security, and consider contributing to open source projects to further refine your skills. Thank you for following along, and I hope this course has armed you with the knowledge and confidence to tackle Kubernetes security head-on.